Okay, welcome back. So today we're going to talk about something called trig ratios. And you've seen these buttons on your calculator for years and years and years. We're going to talk about what they are, but we're not using the calculator buttons just yet. We will later on in this chapter, but for now we're just going to talk about what the ratios mean, how to find them, and how to simplify them. So, trig ratios. First and foremost, these only work for right triangles, just like the Pythagorean theorem. So, first thing that you should note is only for right triangles. Depending on how far you guys go, if you end up going to pre-calculus, you can learn how to, or even algebra 2, I think maybe, you can learn how to use these for other triangles that aren't right triangles, but for now we're going to have them be just for right triangles. So I'm going to do my little drawing here of a right triangle again. Got 90-degree angle and this third side connecting those two legs. Now, in a right triangle, if you know where the 90-degree angle is, then the side that's opposite that we've already talked about is the hypotenuse. And up until now, we've been talking about these other two sides here as either A and B or as both legs. Well, they now get different names, and their names actually change based on which angle we're referring to. So when I find the hypotenuse by drawing a line out from the vertex and seeing which side it hits, I'm finding the side that is opposite to this angle. So for my two legs here, if I look for, I'm going to label these angles here. I'm going to call this one A, call this one B, and this one C. If I look at angle A, I can still find a side that's opposite it, just like I could find the hypotenuse opposite the 90. So if I draw a line out here from A, I hit this side, which means if we're looking at A, then this side here, BC, is the side that's opposite. And then the third kind of side there can be is what's called adjacent, meaning next to or part of. And so then that means that CA is an adjacent side. So this is for angle A. Now, this is kind of the first part of diving into trig ratios, is you need to know those three sides. You need to know which side is the hypotenuse, which never changes, but then you also need to find the opposite and the adjacent sides. Now, these are opposite and adjacent to angle A. What if I looked at angle B? Well, angle B is going to have a different side that's opposite and a different side that's adjacent. So if I didn't realize that was going to happen. Oh well. If I look at B now, let me just redraw these. Yoda is participating again today. All right, if I redraw these and I'm looking at angle B, now the side that's opposite angle B is AC. This is now opposite. And the side that's adjacent next to or part of angle B is going to be BC. So this is now the adjacent. All right. Now, the reason that's important is these ideas of hypotenuse, adjacent, and opposite are how the trig ratios are spelled out. So let's talk about what the trig ratios are. There's three of them that we're going to be talking about. There's actually more than three, but there's three that we're going to be talking about in this class. The first one is sine, which is abbreviated just to SIN, that button on the calculator you've seen. The next one we're going to talk about is cosine, which on a calculator is abbreviated to COS. And then the last one is tangent, which on a calculator is abbreviated to TAN. So let's talk about what each of these are. So sine is a ratio of two sides, and it depends on which angle you're talking about, what that's going to be. Sine is the ratio of the opposite side to the hypotenuse. So this is often written as opposite over hypotenuse. It's going to be a fraction or a decimal. In this class, I'm probably going to want you guys to write it as a fraction unless you're told otherwise. The cosine is the adjacent side over the hypotenuse. And the last one is the tangent. The tangent is the opposite side over the adjacent side. So it changes depending on which angle you're using. The only side that doesn't change is the hypotenuse, and each of these have sides that aren't the hypotenuse. So it's going to change based on which trig ratio you want and which side you're dealing with. So when sine, cosine, or tangent are written, they're written as their abbreviated form with the angle that they're taking into account in parentheses. So for example, if I wanted to find the sine of A, that would be written as sine, just like it is on your calculator, and then in parentheses A. Now, do not think that you can just type in the sine on your calculator, because it's not doing what you think it's doing something else. Cosine would be written as cosine COS of A, and tangent would be written as tangent of A. So let's take a look at how these would work in practice. I know this seems super complicated, but this is actually something that gets used quite a bit in the quote-unquote real world. So let's create another triangle here. This one's going to be slightly different. I'm going to put it kind of off kilter here. And I need to make sure that I'm labeling my angles for this in order for you guys to understand it. So this is going to be C. Here's the 90-degree angle. This is going to be A, and then we'll call this one B. And now I'm going to give these sides some lengths. So I'm going to say the length of BA is 13. I'm going to say the length of AC is 5. And the length of BC is 12. This is super not to scale. All right, so I'm going to write a few different ratios that I want you to find. And once I write these down, just take a second and pause and see if you can find the ratios yourself. Or if you find one of them, maybe take a second and pause the video and see if you can find the others. So first I want to find out what's the sine of A. Do this in relation to A, and I'm actually going to change color here since this is in relation to A. I'm going to find out which side is which. So here's the 90, draw a line straight out. I would hit this side, so this is the hypotenuse. Focusing on A here, so if I go from the vertex of A, draw a line out, I hit 12, so this side is the opposite, and that leaves 5 to be the adjacent. So step number 1, steps, is you need to label the sides for the angle. So label sides, I'm kind of getting cramped here, for the angle. All right. Now, once you do that, the next thing is you're going to substitute values into whichever ratio you're looking for. So I'm going to call this sub in values for ratio. All right, so if it's sine, remember we just talked about this, sine is opposite over hypotenuse, O over H. So the opposite side is 12, the hypotenuse is 13. So opposite over hypotenuse is 12 over 13. Don't turn this into a decimal. Leave this as a fraction, okay? If it can reduce, reduce it, but in this case it's just 12 over 13. All right, let's find another one. Let's find the tangent of A. Now I already have the sides all labeled for A. So tangent, opposite over adjacent. Here's a good time for you guys to pause if you want to try it yourself. It's just going to be a fraction, a ratio. So opposite for A is 12 here, and the adjacent is 5, so this is going to be 12 over 5. And leave it improper if it's improper. Don't rewrite that as 2 2/5. Leave it as 12/5. So long as it's reduced, improper is perfectly fine. Let's go for another one here. Let's find the cosine, not of A, but the cosine of B now. So we're looking for cosine of B. So I need to kind of redefine my sides. The hypotenuse stays the hypotenuse, but now I'm looking at angle B. So now if I draw a line out from angle B, 5 becomes the opposite, and 12 becomes the adjacent. So cosine is adjacent over hypotenuse, so that's going to be adjacent over hypotenuse, which is going to be 12 over 13. Okay. For now, that's pretty much all that we're talking about as far as sines and cosines go. We're going to be talking about using these to do things in the quote-unquote real world a bit tomorrow, and that's going to require some use of your calculator. But, or maybe not tomorrow, depends on when you're watching this, the next lesson in the chapter. So So yeah, hope that went well, and I will see you guys in the next lesson. Such a good girl, right?